Today we're going to talk about expectation. So we have already learned about how probabilities can be used to estimate the number of times that a certain event can happen if we repeat that experiment numerous times. So we can find the expectation or expected values in a similar fashion. So our expected value, we're going to use an example to get into this. So if the spinner below is spun, players are awarded the resulting number of points. It says, on average, how many points can we expect to be awarded per spin? So there are two ways that we can do this. The first way, if you add up the total amount of points on this spinner, we will have 15 plus 10, which is 60, and then 5 plus 15, which is 20, which gives us 80 points total that we can earn. So there are 80 points that you can get out of 4 different spins, which would tell us that there's an average of 20 points per spin. Another way that you could do this is you could multiply the amount of points by the probability that you will get those points. So each of these sections are 1/4 of the entire spinner. So if I wanted to, I could say that my average is going to be 1/4 of 5 plus 1/4 of 10 plus 1/4 of 15 plus 1/4 of 50. And if I were to take all of these numbers and multiply them by 1/4, for instance, I will have 5 divided by 4, which is 1.25, plus 1/4 of 10, which is 2.5, plus 1/4 of 15, which is 3.75, plus 1/4 of 50, which is 12.5. So if I were to add all these together, I would end up with 20. So I still get the same answer. Okay? So we can say here, for a random variable x with the possible values x of 1 all the way to x of n, and the corresponding or associated probabilities p sub 1 to p sub n, the expected value of x is given to you by the formula e of x is equal to the summation of my possible values times their respective probabilities. And we also know that E sub x is also known as the mean or the average of the probability distribution, and it is sometimes denoted as the Greek symbol mu. So let's look at example number 1. So it says, below are the probabilities P sub I of how many game boosts are purchased by subscribers X sub I. Find the expected number of boosts bought by each customer and explain what that means. So if I want to find the expected number, then all I would have to do is multiply each number of boosts by the probability of that boost, those amount of boosts being purchased. So here I can say that E of x is equal to 1 times 0.27 plus 2 times 0.39 plus 3 times 0.18 plus 4 times 0.12 plus 5 times 0.04. So remember, you have to multiply all of the expected values by their probabilities. So when we do that, you literally type it into the calculator. Please make sure you pay attention to when you're typing it in, because if you miss one decimal or you make a small mistake, it will throw your entire calculation off. So when we get here, we will end up seeing that we end up getting the expected value of 2.27. So that is my expected value, aka that is the mean of the probability distribution. 2.27 boost, okay? So, if we want to explain what this means, we can just say the average number of boosts purchased will be 2.27. Okay, let's talk about fair games. So in gambling, the expected gain of a player is going to be calculated by taking the expected return or payout from the game, and you have to subtract the amount that it costs that person to play. So basically, it's the amount that they made from the game minus the amount of money that they had to put up to play. A game is considered fair if the expected gain is 0. So let's look at example 2. If a player rolls a die, the table below shows the winnings according to the side that is rolled. So the first thing that they want us to do is they want us to find the expected return for one roll of the die. So remember, the expected return or the expected value of your return is going to be equal to the side number that you can land on times the amount of the winnings, or you can technically say that it's going to be the probability that you will get the certain amount of winnings. So you have a 6-sided die. So you have an equal chance of rolling each side. So you can win $1 1/6 of the time. You can win $2 1/6 of the time. $3 1/6 of the time. $5 1/6 of the time. $6 1/6 of the time. And then $7 1/6 of the time. So if you multiply all of these values by 1/6, it is the same thing as me saying 1/6 times the sum of those winnings. And as you can see here, my expected return is going to be $4. So on average, I can expect to win $4 each time I play the game based off the winnings. So now for part B, it says, what is the expected gain of the player if it costs $5 to play each game? So remember, the expected gain is equal to your expected return per game minus the amount of money that you had to put up to play, which was $5. So we will say the expected return was 4. Subtract the $5 that you will have to put up to play. That will be equal to -1. So my expected gain is -1, or technically, since it's negative, we can call it an expected loss if we want to be technical. So part C is asking us, would you recommend playing this game? Why or why not? So we will say no here because the game is not fair. Remember, in order for a game to be fair, you have to have an expected value of 0. The expected value is a -1, so it is not fair. All right, so have a nice day. If you have any questions, feel free to ask me and I will assist you.